Question 19 gives us the following function. H of x equals x plus 5 times x minus 5. And we are asked to determine what value of x produces the minimum value for h of x. There are several ways to do this problem. One way would be to simply take each answer choice and plug it in for x, comparing the resulting values of h of x. Since we're only given 4 options, it wouldn't be particularly time-consuming to do the problem in this way. A second way of doing this problem would be to actually graph the function in your calculator, and then, if you know how to, calculate the minimum that way. To do this question algebraically, you have to notice that this is a disguised parabola, meaning if we multiply x plus 5 by x minus 5, we get x squared minus 25. Since this is a quadratic polynomial, we know that its graph is a parabola. And so if the question is asking us where the function reaches its minimum, and we also know that we're talking about a parabola, then the minimum has to be the vertex of the parabola. There are a few ways of finding the vertex of a parabola. One way is to use negative b over 2a. The b and the a come from the standard form of a parabola, which is typically written as ax squared plus bx plus c, where a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant. Well, we can see by looking at the function as it's written right now that there is no x term. There's just an x squared. We can think about this as 0x. In other words, the value of b is 0. Negative b over 2a then gives us negative 0 over 2 times 1, which is simply 0. The x-coordinate of the vertex, then, is 0. We could find the y-coordinate if we needed to, but the question doesn't go that far. A fourth way of doing this problem also involves recognizing that the function is a parabola. If you realize that parabolas are symmetric, then you can say that the vertex must be exactly halfway between the x-intercepts. Looking at the way the function is presented, we can see that the x-intercepts are negative 5 and positive 5. The point halfway between those is 0.